So, with that introduction, I think it's easy to understand why data science has emerged as one of the greatest areas to work in these days. So, it has a large job market at this time, and it is one of those areas that hasn't been affected that much by the recent pandemic as other areas. So, it's something that's very up and coming. It has its own set of challenges, but it's really interesting. If our ability to develop algorithms that are able to analyze data and make predictions in an intelligent manner, much like what humans do, is going to be, in my personal opinion, as well as it is being supported by all the recent indicators out there, the recent economic indicators, that it's going to be probably one of the coolest areas to work in, especially for computer scientists. So please follow those trends and keep an eye on those as we evolve through this magnificent time and we are able to generate better and better algorithms to process data. This has become a disruption in some ways, and what I mean by that is I'll illustrate this fact by an example. So this is a picture taken in the 1900 of the Fifth Avenue in the New York City, and what you see is a whole bunch of horse carriages that are moving on the street, and there is only one car, if you can spot that. So that's over here, this one. And if you take the same picture of the same street about 10 years or 13 years later, then the whole of the street is covered by cars, and there's only one horse cart in there, which you can see over here. And this is what I mean by a disruption. In this case, the disruption was in the transportation industry, where a mode of transportation was completely replaced. Now, what I want to say based on this is that what we are going through right now is a similar disruption in which our ability to make algorithms or artificial intelligence and machine learning algorithms is going to disrupt a whole lot of technologies and different areas, including transportation. So on your screen right now is one of the first cars over here that was able to drive on its own. It was part of a project called No Hands Across America. So in the last picture, you saw cars, and they have pretty much stayed the same. But the recent innovation in the development of cars is automation, driverless cars, right? This is a world map of places in the world where some form of automated driving is authorized by law. And we're all familiar with different companies that are producing different types of cars. And at the back end of all of that are algorithms that take in data, visual as well as other sensor data, including GPS, and they're able to make driving decisions automatically. So this is a huge step forward. If you relate it to our previous lecture, in which we discussed driving as a form of reinforcement learning, and we attributed that to human intelligence because we are able to drive more or less, sometimes not too good into good a manner, but this has been it's starting to be replaced by machines. So this is something that is going to be a huge disruption. Now, that is not the only example of the application of data science. I'm going to walk you through another example that has uh, really revolutionized different aspects of our lives without even us realizing that. And that is optical character recognition. So, handwritten text can now easily be read by machine learning algorithms and data mining algorithms, and they can convert that into digital text, much like this one. So the journey for that started off with something back in the 60s, actually, in the very first application of image processing and machine learning started back in the 60s, in which people wanted to be able to recognize digits. And the first successful application was in the post office for mail sorting purposes. So a mail piece of envelope was scanned, and the objective was to be able to automatically sort it and even send it to a particular person whose address was indicated on the envelope itself. So the first postcode reader was successfully implemented by the US Postal Service in 1978. So that's pretty old, right? But it had certain limitations. It could only identify the postcode, the name of the city, the name of the country, and so on. It couldn't identify the name of the person, the street, or anything like that. In 1982, the first address reader was available. So this was, you had handwritten addresses and it could digitize them, and then we had machines that could sort them. So that was a step forward. Then there were machines that could read multiple lines, and those were available in 1984 for mail sorting. Then there were machines that could recognize sender's address back in 1996. And then in 1998, the US Postal Service implemented a whole lot of other systems as part of this recognition framework that allowed it to identify if there were any instructions, such as undeliverable return instructions, written on top of the envelope itself. So that was pretty cool. It could also recognize in 2000s whether envelope was appropriately stamped or not. So it's going to be a huge step forward, and it has been a huge step forward in recognizing and doing mail sorting in a completely or more or less completely automated manner. In 2008, the US Postal Service was able to recognize through machine learning and data mining algorithms uh, both sides of the envelope and perform almost completely automated mail sorting. Now, that, if you think about it from an economic perspective, which I welcome you to do, because it's not just data science, it fits in within a bigger picture of how it integrates into society. On the one hand, it has saved a lot of manpower, and it has probably economized the delivery of letters. But at the same time, there has been and there will be job losses associated with this, as well as job gains. So it all comes together in terms of economics. However, what we are going to focus is the technology part of it, but it's also important to be cognizant of the ethical and economic ramifications of these systems, and to be able to identify any such applications. And one of the assignments, a thought assignment that I would give you is, you don't need to submit it as part of this module, but start thinking about right now and from this point onwards, different applications of data mining and data science that you see around you. So someone came up with this idea that we can drive, we can have autonomous cars. Someone came up with the idea that we can have envelopes that are automatically sorted. Think about these applications. This is what it takes to be a leader in data science in this age. So I welcome you to start thinking on those lines right away. We're going to cover the technologies as we move along. This is just a simple plot on your screen of how the accuracy of uh, optical character recognition systems has changed over time. On the x-axis sorry, is time in years again, and on the y-axis is the accuracy of these systems. And for machine learning, so for machine printed text, we are almost perfect. There are computer algorithms that can recognize machine text for checks, for example. No, although no one really uses checks anymore, or very few people do, but we're able to recognize that quite well. And then multilingual OCR and other types of handwriting, we're getting better and better. So this ends at 2010. But beyond that, it actually has gone significantly better. And current AI systems and machine learning based systems for OCR are at par for more and more languages with human beings. So this is what is called the Turing test in artificial intelligence, in which you will not be able to tell whether it's a human reading something or whether it's a machine reading something. If the performance of both of them is exactly the same. So in terms of OCR, we aren't exactly there. I don't want to make that claim, but we are getting there in terms of OCR, at which a machine is able to outperform a human. Another application that started off with, let's say, face recognition or fingerprint recognition. It was started the fingerprint recognition episode. The whole project was started by FBI, who started maintaining databases of fingerprints and using them to identify criminals and uh, people who had committed fraud of any kind and so on. Then there are other types of biometrics that were available, like hand geometry. Then people started using iris and hand vein and even signature recognition. So all of these biometrics applications are based on a set of data science and machine learning algorithms. that allow us to identify different types of patterns that are specific to a particular individual. And the culmination of that is now you have machines in the palm of your hand that allow you to do this. So you are able to log in into your phone by using your fingerprints. So that's a pretty good step forward. And that's a good application or a good application example of data science. Okay. Similarly, if you think about on the same lines as biometrics, once you post a picture to Facebook or if you post it onto Snapchat or uh, any picture service like that, they're able to identify different people. So if you have posted a picture and Facebook comes back to you with proposals of of what people were in that particular picture, on the back of that is an algorithm or a modified form of an algorithm that we are going to talk about in this module as well. Similarly, image recognition or object recognition, by that I mean recognizing what this is. So this is a mouse. Most of you will be able to recognize that. And in my hand over here is a pen. You would be able to recognize as well. So object recognition and image recognition, the, the accuracy of machines has now, for a particular data set, for this image net data set, that you see on your screen, which is composed of different types of images and has a number of classes like aeroplanes and animals and people and backgrounds and cars and so on. So the accuracy of machines in recognizing different types of objects in this database is now actually better than what humans are capable of for most cases. So this is a huge step forward. And on the back of this are algorithms called convolutional neural networks that we are going to talk about in this module as well. So hang in there. Similarly, not only can AI recognize different types of images, it's also able to recognize voice patterns. So these voice assistants, such as Alexa, Siri, Google, or Cortana, they're able to now identify commands as well as conversations, and that has led to it has it has improved our quality of life, but at the same time, it has opened up privacy concerns. So it's important to realize that and to think of that. So in 2017, it was the first time that a machine learning algorithm for speech recognition was at the same level as a human being at about 95% accurate. And this is the word accuracy on the y-axis, and this is the time. And as you can see, over time, machine learning algorithms got better and better. And now we have algorithms that match the performance of human beings. So that's pretty cool. Similarly, natural language processing is another area in which data science and machine learning has been used to identify patterns. So one of the patterns, for example, can be identifying spam in different emails. So on the plot on the left-hand side, you see from 2004 to 2007, the amount of spam that was generated across the world for Gmail had actually gone up, but Gmail was able to use these patterns that are specific to spam and build a machine learning model that enabled them to identify and stop these spams from spreading too far. So the amount of spam that got through actually dropped, even though the spam that was generated has increased over time. And this is one of the success stories that we use every day in our daily lives. Email, so spam detectors are based on data science and they are based on machine learning algorithms, such as natural language processing algorithms. And they have gotten better and better, and we use them every day. Now we have come to a point, and this is a very exciting time to be here, that we have these algorithms such as GPT-3 and other algorithms, which are deep learning based algorithms, and they can generate text. So what you see on your screen over here on the right hand side is a poem that has been generated by an AI. So this is the AI was fed data from Shakespeare's poetry, and it was able to generate a new piece of poetry all by itself, and it makes sort of sense. I welcome you to read it in your spare time. Okay, so moving on, another successful application of machine learning models that we has been very useful for me at least during the pandemic is our recommender systems, not only for watching movies on Netflix, which again models user preferences or patterns in user preferences, much like what we discussed in our previous lecture, to be able to generate predictions for what is whether I would like another movie or not, whether I would like a certain show or not. Similarly, these recommender systems are used on Facebook as well in generating your suggesting you friends and suggesting you groups. So all that is based on what is called recommender systems. And we are going to talk about these briefly in this module as well. Think about other examples of these recommender systems and identify where these would be useful. Would you want to have a pizza that is customized for you? Maybe you need a pizza recommender system. At the same time, you must have used Amazon, and it has a pretty good recommender system that says if you bought something, they may suggest you other items that you may be interested in. These things aren't perfect, and we are going to talk about their limitations as well. So, for example, one story that about Amazon, and this is just an example, not specific to Amazon, but in general for different type of recommender systems. So, let's say if you bought a laptop bag, then Amazon or any other recommender system for shopping can come up and suggest that you buy a laptop now, which doesn't really make sense because why would I need a laptop bag if I didn't have a laptop in the first place? So there are certain limitations here as well, and we're going to talk about those towards the end of this module. But before we do that, we are going to study what the technology behind these recommender systems actually is. Similarly, it has machine learning has been used in computer security. So if you are interested in computer security, machine learning, and computer security, it's a marriage made in heaven, and there are so many applications of machine learning in computer security. So this is an example in which of taken from this particular paper in which they were able to identify what text is being typed using a microphone that was placed a certain distance away from the keyboard. So you use patterns of how a key sounds on the keyboard when a user presses it and relate it to what text is being typed. So this is a side channel attack on on computer security systems. So this is a whole new area if you want to discuss, or if you want to look further into that. Similarly, gesture recognition or those sci-fi cool movie things. Now we have those in different types of gaming consoles available to us. So that's also uses pattern recognition and data mining in the background. We are also there are AI algorithms that are now able to generate images. So the pictures that you see on your screen, none of those persons actually exists. An AI algorithm was fed in images of real people, and then it was asked to generate images for of different people given a certain set of parameters as input. So this is what is called generative modeling as opposed to discriminative approaches. So I'm just going to type it here for your notes. In generative AI or machine learning models, we are interested in generating an output or a sample at the output of a machine learning algorithm. Whereas in discriminative approaches, what we want to do is to be able to discriminate or identify two different objects which are given at the input of the machine learning model. So that's the difference between the two. So if you walk into an interview and someone asks you what's the difference between generative and discriminative approaches, you should be able to answer that now. Okay. AI has been used for games, but machine learning, the development of machine learning algorithms for playing games, computer games, has recently really picked up. So on the left-hand side, you see a bunch of Atari games, and now there's a player that uses reinforcement learning techniques, and this is by DeepMind at Google, and they're able to take data of the machine playing with itself and to solve different types of games. By solve, I mean you cannot beat an AI for these games anymore. It's beyond that point. Similarly, the toughest game that AI has been able to master recently is a game called Go, and there is an algorithm called AlphaGo, which uses pattern recognition and machine learning technologies, much like what we are going to talk about in this module. Perhaps not in too much detail, but we're going to discuss those. And they're able to use data from games and to be able to learn to play this game of Go. And it has beaten the human world champion of Go. So computer beating a human. So that makes it a strong AI. So we have a strong AI now of Go with us. Okay. These technologies have had a recent breakthrough in biology as well, and much like the game developer, the development of AlphaGo, there's now an algorithm called AlphaFold, and that has been a huge step forward. And it can be, and this can be realized by reading this text that is on your screen. It's going to change everything. So let me give you a specific example. Currently, we are going through a pandemic, and we want to design drugs that are able to stop this virus. One way to do that is to be able to identify those proteins and then design specific drugs that can target those proteins. And what this AI allows us to do is that it allows us to predict protein structures quite fast in comparison to what we were able to do earlier. And this has been a huge step forward for drug design as well as understanding biology. So, as a bioinformatics, the bioinformatician in me is pretty excited at these developments. Okay, so far what we have covered is a bunch of different applications of machine learning, and the goal was first of all to make you aware of where we are at with different types of machine learning algorithms and data mining algorithms. But the real goal I have in mind is to inspire you as students to start thinking about not how we are going to solve it, but what are we going to solve. You should be able to identify different types of machine learning problems around you. And that would be a huge step forward if you want to say, solve a new problem. I'm going to teach you the algorithms that you would need to solve those, but coming up with problems is something that you can learn, you'll be able to learn on your own. So, depending upon who you ask, what is machine learning or what is data mining, you can get different answers. So, if you ask the society what we do, probably they're going to say that we do some robotics. And if most of my friends, well, they can think that I do some weird stuff with the computers. And because the field is is so much in demand, other computer scientists may think that we roll in money. It's not true, by the way. There isn't that much money unless you come up with a really cool idea. And most of the other people, they think that most of the time, what we do is design recommendation systems like on Facebook or Amazon, or spend some time in designing these apps. As a machine learning instructor, what I think I do is to develop the mathematical basis that allows us to do all of this and then implement them in machine learning, like coding, and it's pretty hard work. So what I'm going to teach you is primarily this bit. So what I think I do and what I actually do, so that you can design and you can develop novel algorithms for different machine learning and AI applications.